Hello, everyone. Thank you for joining MSCG's webinar on Resurgence Beyond Supply Chain Disruption. This is a 60-minute session with about 55 minutes of presentation and SAP IBP demonstrations and 5 minutes of Q&A at the end. Just as an FYI, this is a recorded session. Please be on mute as a courtesy to your fellow participants, and feel free to use the chat feature in Zoom to post your questions ahead of time, and we'll get to it in the Q&As. With that, I will hand you over to Dan Bidet to introduce the team and run the session. Over to you, Dan.
Thank you, Samir. Good morning, good afternoon, and good evening, everyone. Thanks for joining us today. The topic of today's webinar is Resurgence Beyond Supply Chain Disruption. And this is a second webinar in a series by my supply chain group along this theme. After quick introductions of the speakers and my supply chain group, I will quickly set the theme for this Resurgence Beyond Disruption. And then our subject matter experts will walk us through the live demos of each of the three scenarios. Todd Stenger from SAP has joined us, and he will walk us through new functionalities, new features in SAP Integrated Business Planning, release 2005. After that, I will then speak briefly about our SAP IBP Jumpstart offering, followed by the Q&A session. My name is Dan Bidet. I am the co-founder and partner at my supply chain group. In the interest of time, I'm going to take liberty introducing my other colleagues, Mahesh Latkar, Sanjay Sabhagani, and Praveen Ramchandran, are subject matter experts with 12 to 15 years or even more of experience in supply chain planning and in consulting. My supply chain group is a premier enterprise consulting firm. We offer innovative solutions in supply chain strategy, process reengineering, and application integration. MSCG was founded in 2008. Our head office is in the US with subsidiaries in Canada, Mexico, and Asia Pacific. We have more than 60 clients and more than 160 consultants and counting. We have our industry experience spanning more than 15 to 18 different verticals, including consumer products, energy and oil, life sciences, high-tech, heavy manufacturing, aerospace and defense, and so on. Among the key SAP solutions that we help clients with, they include, on the planning side, SAP Integrated Business Planning and Advanced Planning and Optimization. Also, production planning and detailed scheduling, advanced available to promise in S/4HANA. On the execution side, we also help clients with S/4 embedded and core, extended warehouse management, transportation management, and yard logistics. In the supply chain arena, we are known for our thought leadership, for the cost-effective solutions that help ensure value maximization and risk mitigation for our clients, because we also incorporate best practices and policies throughout our client engagement. We all are at the suffering end of this global health pandemic. All of us are also seeing that the US-China trade tensions are rising. We have all experienced the volatility in the global stock markets. All of us are aware of the lower demand for oil and the crash in oil prices, resulting in a glut in supplies of oil. And all these factors have contributed to a fear of an impending recession. In fact, many people think that we already are in a recession. And given all these aspects, in our previous webinar, we had talked about how to comprehend the big picture of all these demand shocks, supply shock, and the financial shock that we are all going through, how to put together mitigation strategies and action plan, and then how to restore, adapt, and lead again with short-term, mid-term, long-term plan. We are not going to go through those aspects, but we had presented a full-fledged Agile Assessment and Action Plan methodology in our previous advisory webinar. Today, we are going to take that system agnostic approach forward and include specific demonstrations of how to handle three different types of disruptions that all of us are experiencing, with actual live demonstrations of them with SAP Integrated Business Planning solution. At a very high level, they include a scenario with supply shortage that would force us to prioritize demands for different finished goods or customers. another scenario that relates to the excess supply, like in the oil industry, and see how that may force us to consider building up inventory for certain finished goods. And also a network disruption scenario, which will prompt us to look at alternative sources to incorporate resiliency in our network. In each of these scenarios, our objective is to demonstrate on-the-fly scenario planning capabilities for agile response. We all understand that in real life, multiple scenarios and in fact, multiple occurrences of the same scenarios overlap on each other. But for the sake of striking the right balance between simplicity and complexity, we are going to go through each of these scenarios individually by themselves as you go through it. You will also see some real-time planning, visualization, and exception-based management capabilities. And this will help you understand how to achieve balance among resiliency, agility, and efficiency across your existing supply network. With that said, I would like to have Mahesh walk us through the first scenario. Over to you, Mahesh. I'll stop sharing.
Thank you, Dan. Hello, everyone. This is Mahesh Latkar. I'll talk about the first scenario, which is component shortage, which can force us to prioritize finished good demands. Our pre-disruption situation is we got a certain raw material or component which can be used to make multiple finished goods. Under disruption situation, we got a shortage of one of the component, and there is no alternative source possible to make this component available in near term. Implications of this component shortage could be it is not possible to meet the demand for all of our finished goods due to component supply constraints. So we have to make a choice between two finished goods, for example, which finished good to be produced first and supplied to the customer. This scenario of uh, for different industry sectors. If you take example of the healthcare, here all types of masks which will need a filter material, but due to shortage of filter material, we have a pressing situation to produce N95 mask as compared to other masks, for example. With high-tech industry, we have constrained supply of CPUs, which can push us to produce higher priority laptops compared to other laptops. With pharma sector, we could have different dosages of tablets, for example, 20 mg versus 30 mg tablets. But due to supply shortage of API, which is the raw material, we may have to produce 30 mg tablets on priority. This scenario can be applicable to CPG as well as dairy industry similarly. This slide talks about how we can prioritize the finished good demands and what all prioritization can be possible within IBP system. So finished good demands can be prioritized based on your product, customer, or it can be prioritized by demand type. On product prioritization, we can consider various factors like how profitable your product is or what is the strategic importance of the product. Also, with respect to customer prioritization, it can be set up based on which customer has more demand volume or which customer brings more revenue for the organization. Similarly, we can set up the prioritization by demand type. It could be your customer order compared to your internal demand, for example, forecast or safety stock. All of these priorities can be modeled using various cost or penalty parameters within IBP, which goes input into the IBP supply constraint optimizer. So cost parameters can be set up at finished goods or customer level or by demand type. We cannot achieve the same level of results with unconstrained heuristic, and it will need a lot of planners intervention. We can also make use of quota arrangements while using unconstrained heuristic. On this slide, for this component constraint scenario, we have set up two finished goods here with multi-level BOM, and we have a common material which is IBP 399R, and we have a BOM ratio between this finished good and constraint material is 1:1. So this IBP 399R is our supply constraint, and we are using other components along with that. At the bottom side, you can see the supply chain network having one customer to the right and one DC 1720 and manufacturing facility 1710. Finished good is produced at 1710 location on multiple resources, and we have a supply constraint component here, which can be used to make these finished goods. Now let me switch over to the IBP Excel to look at our data setup. So here you can see there are various tabs at the bottom. These are called planning views, IBP planning views. There are two simulation versions on the left side. One is for heuristic and one is for optimizer. We'll first focus on optimizer scenario. So here we got two products, IBP 300 and IBP 310. These are finished goods, and we have one customer. You can see to the right side, we got demand of 300 in each week for IBP 300 finished good. And for other product, we have demand of 200 in each calendar week. Now I'll move to next tab, where you can model our material constraints. This is our component, IBP 399R, and this is our manufacturing facility location, 1710. Here we can see that we got a supply of 350 units available in each of the calendar week, and this can be used to make our multiple finished goods. Now here thing is that in the first tab you got demand, total demand of 500 in each bucket, 300 plus 200, but supply of only 350 units. So with this setup now we can see how IBP can prioritize our finished goods and which finished goods get more supplies. In the next tab, you can do this prioritization using non-delivery penalty cost. So we have same scenario, optimizer and two finished products. So this is the example of your prioritization based on product. So here we got two finished goods, and if you look at this first 2 weeks, it has got more penalty compared to other product, and in next few weeks it has got less penalty, and for other product it has got higher penalty. So with this setup we can see how we can prioritize our finished goods. Now after running or executing the supply planning optimizer, you will see the result in the last tab, which is customer supply tab. And for this optimizer scenario, now we had a demand of 300 for this product. If you look at first 2 weeks, and it has fulfilled all of its demand in first 2 weeks because of the higher penalty setup. And for other product, we got demand of 200 in these 2 weeks, 26 and 27, but it could only supply 50 units. Okay, this is due to your lower penalty rates for this product. Now, similarly, the situation is reverse in next few weeks. So here we got same demand of 300, but it could fulfill only 150 units in each of the week. But if you look at on the contrary, other product has got a supply of 200 in each week. So this is how you can model this supply constraint and also product demand prioritization by product using this kind of setup. Now let me switch over to the web-based part of the IBP system. Now this was IBP cloud-based Excel. If I go to the dashboards, so here we got multiple dashboards. These two charts are relative to each other. So with this top chart here, we got the component IBP 399R, and here we can see that there is a supply available of 350 units. In if you take example of 4 weeks, in 4 weeks we got supply of 350 units available. On top we got two finished products, and this blue is your demand, and this orange or brown is your supply. At the bottom chart, you can see red bar is represented by your consensus demand. Green bar represents customer receipts or supply committed, and black bar is your penalty. So if you look at this 2 weeks, calendar week 26 and 27, for the product IBP 300, you got higher penalty, 20,000 each. And here you got demand of 300, and you can see all of its demand is fulfilled for this first 2 weeks for the product IBP 300. And next 2 weeks, week 28 and week 29, here you got higher penalty for IBP 310, other product, and demand of 200 is fulfilled by this supply of 200. Okay. Now let me show you some alerts generated. So this is the third chart where you can see supply shortage alerts, and this alert icon at the bottom, this top left. For first 2 weeks, 26 and 27, you have this alert for supply shortage alert for IBP 310 product. Here we can see that there is a demand of 200, but it could fulfill only 50 units of demand. Similarly, for this week 28 and 29, you see alert for IBP 300, other product, finished good. And here you have demand of 300, but supply available is only 150. So likewise, you can model this supply constraint and product prioritization using all of this data setup. Now let me go back to my presentation. So in summary, we have seen that we have demonstrated how demand can be prioritized to counter component shortages. We also seen how different cost parameter can be set up and can be used to model prioritization of different products, customers, or different demand types. And one thing to remember here, so in the IBP planning view, I had set up all this data in the scenarios. Those are called simulation scenarios. So once you're happy with your results, you can always promote your results into the baseline scenario, which will be your live version. With that, I'll be handing over to Sanjay, my colleague.
So, hello everyone. My name is Sanjay, and I'm working with my supply chain group as a subject matter expert in supply chain planning using various SAP tools. For this webinar, our focus is on SAP's IBP functionality, and I'd like to walk you through the demonstration of the second scenario in today's webinar. With that, I'll just move to the slideshow. So this scenario basically talks about an excess component supply forcing a ramp up of FG safety stock. The pre-disruption situation in a hunky-dory world, basically I was using a single raw material, certain raw material or a component to make multiple finished goods. Now, once all of this disruption happened, what we are depicting in this scenario is the demand for my finished good goes down significantly, but yet I cannot stop my contractual obligations. I cannot stop procuring my raw material because I have certain contracts with my vendors or unions, etc. So there's quite a potential for excess raw material. Now, the implications of such disruption, or where I have an excess of raw material and a decline of some finished goods, is forcing me to get into a strategy called as push production, and therefore a ramp up in the safety stock for that. Now, this is one of the strategies that we are trying to demonstrate through this scenario. There could be multiple, which can be modeled in various ways using the functionality of SAP's tool, which is Integrated Business Plan. Now, there are relevant examples of different industry verticals, dairy industry being one, energy and oil industry being the other one, and auto industry. So like in an auto industry, plants may not be able to shut down despite reduced auto sales. We've seen that, which has been very common in the past. Now, like I said, the strategy that we are demonstrating here to counter the disruption is increasing of the production and ramp up of the stock. Basically, we are trying to model the longer shelf life of the product here and a product that's more profitable. On the right-hand side of this tabular chart that we present here are some of the enablers for both unconstrained heuristic as well as the optimizer. Now, for our focus today, we are looking at the constraint optimizer, where we'll update the target weeks of supply. We've actually updated it. We've built that master data, and we'll show how it builds up this safety stock. We'll also show how, by levering around with a cost or a penalty parameter at the finished good level, such as an inventory holding cost, how that reflects shelf life of the finished good, and how all of that looks like as an output of the planning engine that SAP IBP's tool suggests. For this scenario, we are using a very simple bill of material here, and the example is basically one from the dairy industry that's been my past experience. So we're using this component raw material at a certain plant, 1710 in the system, that goes into multiple finished goods, cheese, yogurt, and pasteurized milk 1 gallon. So this pasteurized milk 1 gallon here that we're talking about is the retail milk, and cheese obviously everybody knows is a finished good. So we'll try to do a comparison and show how it does that switching of the production ramp up. So like we said, inventory build up to consume the raw material based off the decreasing demand of one of the finished goods. With that, I'll take you through certain data views in the IBP system. We'll look at where and how the planners can incorporate their inputs, do a what if, and then we'll analyze the planning results. One beauty that I'd like to highlight about IBP here is the alerts and the dashboards, which we just saw in the previous scenario as well. So we'll see how a planner can come in on a day-to-day basis and simply take a glance of the dashboard, and it gives him a clear picture, just like when we sit in an automobile, we know what speed it's running at just from the dashboard. So I really love that functionality of IBP. With that, let me take you through the IBP Excel version. So this in front of your screen right now is the Excel version of IBP. I have multiple views here, about 5 of them that I'll run you through. This view essentially talks about the demand for my finished good. Like I've been speaking through for the past 5 minutes, cheese versus pasteurized milk 1 gallon is what we're trying to do a comparison here. Now, I have 2 scenarios. I've named them one as baseline scenario, which is essentially representing my pre-disruption era. In a hunky-dory world, everything was nice. That's my baseline scenario. The second scenario, I've named it as excess component supply, wherein post-disruption, I'm seeing how the excess component supply is going to push me towards the strategy that I just spoke about. To give you a highlight here, I've just marked this particular row here, which talks about how my demand for the pasteurized milk 1 gallon reduces in the post-disruption era. So initially it's about 1,000, and then it keeps decreasing to 900, 800, and 700, and then probably just, for this example, stays at 700 throughout. Whereas in the pre-disruption or the regular times, it was kind of 1,000 throughout, so I've kept it that way. Now for this example, we've taken like 1,500 units, 500 to cheese and 1,000 here. And the component supply, that's the raw milk, I'm saying on a weekly basis, every week I'm getting in 1,500 of those based off my contractual obligations with this particular vendor here, flows into this location here, and that's my 1,500 units of component supply that I need to keep taking. Now, with the demand and the constant supply, the next thing that I'd like to show you is the optimizer costs. What are we basically trying to do here is, for my raw milk, I'm telling the system that the inventory holding cost rate is pretty high. The one marked in yellow here, I put it as 40 across for everything. So what we are trying to model here is a higher inventory holding cost rate for a raw material signifies a lowest shelf life for this product. I cannot store my raw milk for a longer period of time. Whereas cheese, I can store it for a little, quite considerably a longer period of time compared to my pasteurized milk gallon. So you see a lowest cost rate here for inventory holding cost tells the system that it kind of has a higher shelf life and vice versa. So that's what we are trying to play around with here. This is one of the levers or the parameters that we chose to play around and demonstrate in this scenario. At the same time, I'd also just like to highlight this input basically is nothing but the input key figure for optimizer. It basically defines the cost for, as the name suggests, the cost for holding the inventory for each product unit and period. So if you, a little more detail of that, basically, if to calculate the total cost of keeping the projected amounts of products in the stock, the system looks at something called as a projected stock of that product, and then it multiplies that with this rate, and that's how it calculates the entire cost that are used as the optimizer inputs when the engine runs. Also, we are using another parameter here which is an input for the optimizer again, called as target periods of coverage. And in my subsequent presentation, I'll also show you how we are using this as one of the alerts on the dashboards. So this is nothing but the number of future sub-periods wherein I need to have an additional coverage to build up the safety stock. So I'm saying for cheese, I put it as 8 weeks. So it builds up that much amount of targeted safety stock in the future. With all of this incoming in demand and the component supply and these parameters that I spoke about, we run this particular engine and then look at what it tells us or suggests us to produce or not produce. And therefore, it kind of helps to define the strategy that we just spoke about. So let me quickly just run you through this one, and then we'll move to the web UI part of IBP. Here, for my finished good cheese, let's take the first one. If you look at the baseline version, which is nothing but the pre-disruption, it said that I would probably do 51,000 of your seats. And pasteurized milk, it was doing considerably higher because I was selling pasteurized milk 1 gallon in my retail stores at a pretty decent rate without any disruptions. But now here comes the disruption, and the demand for pasteurized milk was lower, as I showed you. So now it tells me I'll make only 70,000, and it bumps up the 80,400 for cheese. So it's asking me to actually start stocking in cheese, and that's how we use this push production strategy to ramp up the stock of cheese. Now, because it has a good shelf life, I'm okay to store it, and therefore I'm trying to combat my disruption scenario using this functionality. So it's pretty straightforward, but it still has those complicated levers to play around with, and we chose to depict a kind of a balance between the simplicity and the complexity of this. With that, let me take you through the web UI part of it. Now this screen here, if you look at this URL here, is the web UI for my IBP. I deliberately have this open because it shows you multiple tiles, and this right bottom tile here shows dashboards. When you click on dashboards, it takes you to something which looks like this. Now, the first one here is the one that I've marked as my favorite. When I click on this one, it will take me to this third tab here, which opens up all my analytic charts and my custom alerts that I've put in on this dashboard. So if you recollect, I spoke about that a while ago, wherein the planner comes in and has a look at this beautiful dashboard here and gets an idea of what's going on at the click of a button. And then based on his manual intelligence, he can decide what needs to be done further. So this first two charts here simply show my baseline production plan versus my post-disruption production plan, cheese and pasteurized milk. So here, if you see, my cheese was considerably doing lower than my pasteurized milk, but post-disruption, as my demand reduced for pasteurized milk, it goes down, and then it asks me to bump up the cheese. So it shows clearly what we are trying to depict here on our scenario. Now, if you look at the alerts, this third chart here talks about the alerts, and it's neatly symbolized by this warning sign here called as alert. Here, I'm just doing a comparison of in each week where my target periods of my projected periods of coverage moves higher than what target I had set. We could build multiple such alerts based on the needs and the requirements using the functionality, but this is what we chose to depict here today. So that kind of summarizes my dashboards and analytics. With that, let me just do a quick summary here. So we basically demonstrated how the excess supply of a component can be countered with push production of certain finished goods, and showed how the different parameters can be used to do a what-if simulation to explore options. I think with that, I'll hand over to Praveen for our third scenario. Thank you very much.
Hello, everyone. My name is Praveen. Thanks, Sanjay. I work with my supply chain group as an IBP SME. I'll try to cover the scenario 3 that we talked about earlier. Basically, we're talking about network disruption, prompting alternate source of supply. I'll just take you through how we can map it in IBP. Let's say your pre-disruption scenario was where you had one supplier and he was the primary vendor and was exclusive, and post-disruption, now you have to look for an alternative. He cannot provide you all the components. And the other scenario is where you, as a company, you want to develop an alternate source to get your components. Well, the implications are obvious that you are not able to get the components, resulting in the shortage of finished goods. You have practical examples today where the automotive industry, some of the regions were completely closed for production. Semiconductor industry, where the supplier has to divide its capacity across multiple customers, resulting in shortage of supply for some customers. Or healthcare industry, where you got opportunities to develop new vendors, take that opportunity and hedge yourself. Let's look at strategies that you would normally use. You have create a new vendor for alternate sourcing. How IBP enables, basically with heuristics, is that it allows you to put quota arrangements against these vendors. When you go to constraint optimizer, which is a constraint tool, you can use the min-max ranges, and you can also use the differential for the cost and penalty parameters. The other strategy to look at is product substitution, wherein you can use alternate BOMs or production quota. In optimizer, you can also use the product substitution. But for this particular presentation, we are going to focus on the scenario 1. So quick look at the bill of materials here. You got a finished good, a semi-finished, and the raw material that goes into the semi-finished. That's the focus for our discussion in the next few slides. As you can see, IBP gives a great supply chain analytical chart here, basically saying as the demand flows from customer to DC to the plant, you got a recipe here, an SFG recipe, and this is our focus, 201R, which is the raw material. It can be procured from 2 vendors. The reason you're seeing 2 vendors is because the master data has already been mapped for this scenario. They are both available for procurement as of this scenario. So let's jump onto the Excel-based planning views, basically, and look at what we have. So this is your location, and this is your DC. So you got a demand, consistent demand of 1,000, purely from the simplicity of calculation in this particular presentation, a consistent demand of 1,000 here. You can see that net demand is populated on the location plant from the next week, because we have a stock on hand of 1,000 for the current week. We got 2 scenarios that we're going to discuss here from a heuristic standpoint. You can see the way IBP works, the flexibility of having multiple scenarios with same set of mass data here. That's the advantage. You can look at different scenarios and still be able to promote one to the final scenario. So this is the location sourcing that we would use for heuristics. For our base scenario, since primary vendor was the exclusive supplier, he would supply the 100% of the components. For our scenario where we want to have 2 suppliers contributing to the supply, and because the second supplier cannot start from week 1, he needs some time to ramp up, we will slowly ramp him up, providing him an opportunity to get to a steady state in a few weeks' time. Once we run heuristics on both scenarios, we want to extrapolate the results with what we have added as a location sourcing ratio. If you look at the base scenario, obviously all the supply is coming from a primary vendor. If you look at the second scenario where we wanted to split the supply between two vendors, since this is a primary vendor, he starts with a high supply, and the secondary vendor gets ramped up here, slowly getting into a steady state of supply after a few weeks. Now, let's say in week 34, one of the vendor calls up and says he cannot actually supply as agreed before in the vendor collaboration call. You could actually, as a planner, go in and plug in a number which allows you to fix the supply from each vendor and then run the heuristics. The heuristics looks at these override key figures and says, you know what, I've got a planner adjusted number and I'm going to promote these numbers to my suppliers, and then the heuristics will show the results as per your adjusted numbers. Now, the same scenario, we can do it in an optimizer. I'll jump onto optimizer. A little bit of variation here, since an optimizer works on a constrained parameters. We have a couple of key figures here, which calls for minimum location sourcing quota and maximum location sourcing quota. So let's say we are in post-disruption scenario. The first scenario, we already checked where vendor was the sole supplier. In this case, again, both vendors are going to supply components to you. As we discussed, the second vendor needs time to ramp up, and we are providing him a min-max ratio, which allows him to ramp up. And eventually we want to stick to a consistent 20 to 30% from vendor 2 versus 70 to 80% from vendor 1, which allows us a little bit of leverage to play with the numbers across both the vendors as and when needed. Let's say we're an optimizer on the set of data that we saw. We saw first week is going to be completely supplied by the primary vendor because we had said he could get all the maximum ratio. From the second week onwards, we could see that the secondary supplier is starting to supply components based on our location sourcing ratios and quotas. Let's say in week 31, a vendor collaboration dictates change in the transportation cost, saying that one of the vendors has increased the transportation cost. We actually went back and applied a higher transportation cost for this week. If you look at this week, there's a higher transportation cost for one of the vendors versus the other one, the system immediately replicates that in your output, saying that because the cost is higher on this vendor, I'm going to supply more from this vendor. In another scenario where, again, based on vendor collaboration, the vendor agreed, saying that I'm not going to be able to supply beyond 55% of my total commitment, you have an opportunity to go and plug in these numbers here. The optimizer will run on this set of data and populate your final output based on what you have put as a transport supply adjusted, basically a planner override that supersedes all your original calculations. As we've already seen so far, IBP provides some cool analytics, and that's probably the best feature here. You come in the morning and refresh your analytics. I can create my own dashboard based on my scenario, my sub network, and my data. You think and you put it here, basically. So what I've done here is you got, let's say, these are the sourcing ratios for each vendor between the domestic supplier and the supplier from outside. And you can see how the domestic supplier has slowly increased the location sourcing ratio. What we would expect as we look at the analytics is the appropriate ratios of the supply, which takes it to full supply from initial primary vendor, slowly moving on to a steady state. And then this is an outlier. I can always go back to my Excel and see, hey, what happened here? Did I make some changes or something else changed? So looking at this one chart, I know there is some change here, something has happened, and I can correlate with what has happened. From an optimizer standpoint, it's again, it allows you to populate the min and max here. So this is how much you can maximum procure, and this is how much you can do minimum for the two vendors. This is for the vendor one, this is for the vendor two, and slowly you're ramping up the vendor two to get to a steady state. Again, the output here should reflect what you have in terms of your min-max, and any outlier you are able to and should be able to correlate to what changes you made in Excel sheet or based on any discussion. And all this also, because you had multiple scenarios, you can just split based on scenarios and then promote the right scenario to the production. So having said this, let's quickly jump on to the balance slides here. We talked about the dashboard. We talked about the input data, the planner inputs. We analyzed the results and with the dashboards as well. So what we are saying in summary is basically you got alternative procurement that would help to counter a disruption. You can have agreed sourcing ratios that you could use to reflect the output from each vendor. Parameters like min and max for optimizer. Along with the transportation cost, you got multiple levers there, allows you to take into account the procurement from each vendor. Other than that, the best case scenario is, this is what you're going to procure from a particular vendor, intervene into the system manually, and system will allow your results to supersede what it has run. With this, I hand it over to Dan for the next steps. Thank you.
Thanks, Praveen. But Todd, would you mind walking us through the new features in SAP IBP release 2005?
Okay. Can you hear me? Dan?
Yes.
Okay. Hello, everyone. I apologize for not being here for introductions in the very beginning. I was running a little bit late. So I wanted to go through just a very high level, some highlights of the 2005 release, which came out in May of this year for IBP. So we'll go through these. This is not an exhaustive list. And then I've got some links at the end where you can get the full list of all the new things. So a couple of key things that we have. We were just talking through some of the analytics. There's also, in addition to some of the analytics, there's an actual Fiori app in IBP called Intelligent Visibility. And we can do geocharts on that. Those geocharts now can use external vendors. So if you're a company that has already something with TomTom or here for doing mapping, we can actually display the map so it matches up with any other applications that you're using. This is also true for the analytics, for any geocharts in the analytics. The other big thing in intelligent visibility is that we can look at order-based alerts. So alerts based on actual orders in the system, not just time series data. And that also can include the gating factor calculations if you are doing the tactical supply planning. And so we can see that, there's a screenshot of here, that we can get into that, and then we can branch out to the other Fiori apps from there. So that's a key thing in intelligent visibility. This is a place where we're spending a lot of development resources. So you'll continue to see things moving forward in that area. If we go to the other big thing that we did from a user interface perspective is that we made a big change to the Excel add-in. So we've decoupled this from other SAP applications, another SAP application called SAP EPM. So this allows us to have some better stability, maintenance. It means that from an IBP perspective, we're not coordinating with any other groups for any changes we're making to the user experience within Excel. This will actually be something that there are tools within the system to migrate all of the templates and sheets that can be done. So all of your Excel stuff will work. However, if those things are migrated, they will no longer work with the older versions of the add-in. So really you should move everybody at one point in time, right? So it's something that would need to be scheduled, but it allows for some additional functionality as well as some better future development from our perspective. We did do a couple of key enhancements though, in addition to the overall new add-in. And this is an offline mode. So you could send spreadsheets to colleagues that were not using IBP or to external people if you wanted to. There were some kind of quirky things if you did that. We now have an explicit offline mode that you can specify for a planning sheet. And then you can send out to any users that do not have the IBP XL add-in installed. It does some conversion for the macros for users without IBP. The external user can then open it up. They will only be able to edit the input editable fields, so matching up with what IBP is. And then when they return it, you can set it back to online and save your updates. So it's a little more, this can enable some external collaboration processes if you're working with subcontractors or even customers putting in forecast. The other big thing is multi-language support. So there is actually a place to maintain translations and everything in the multi-language support Fiori app. We now show that in Excel in the edit planning view with tooltips, planning views, filters, master data workbooks. So we actually do support the multi-language. So that means that you will see descriptions, those types of things, master data descriptions in the languages that you want from the global implementation perspective. If we go to the other UI that we have, really web-based planning, we've got a couple things. There's some other smaller things in here, but we've done basically a side panel so that you can view the settings for the view. The other big thing is that we're showing order data, so detailed order data within the web-based planning, right? So the screenshot down at the bottom kind of shows this, is that there's an icon that shows you whether there's order data. Then you can pop up a table showing you details of the orders. You can also then punch out to some other applications to get additional details on the orders, right? So there's more things around that, but just this concept of seeing detailed orders in the web-based planning views. If we go to some more sort of functional areas in demand planning, we've got a few things. One is that we brought in change point detection in the 2002 release. We're now actually using that within specific algorithms within statistical forecasting. So that will allow you to, actually if there's a change point, it will then shorten the history that you're using. We've also done lifecycle planning at an aggregate level. So the idea of doing maybe a brand level, or in this case, the example on the bottom of the screen is a brand level phase in and phase out for new products. If you do that, you do need to run the statistical forecast at the aggregate level still. So this is not exactly aggregate settings and then running things at a detailed level. This is actually running things at an aggregate level within your structures. There are some additional enhancements coming down the road for doing some of the aggregate and then the detail. We can also from a demand sensing perspective, we have two things. One is we do variable daily split patterns. So basically this means that over time in the future, there's a new option in demand sensing using machine learning to have those be variable. In the past, we calculated a daily split and then just use that for all of the future weeks. We now have week-specific daily splits. The other pieces, and this is the bottom right-hand corner, kind of shows a little bit of this, is that we can exclude historical periods from demand sensing. So basically outlier periods that you want to exclude, we can actually exclude those now, mark them for exclusion, and then they will continue to be excluded from the demand sensing algorithm. If we look at supply planning, there's some key enhancements both in the more strategic planning or bucketed and then the more tactical planning. The biggest one is probably the transportation and production calendars and the strategic planning. So the optimizer that you saw earlier, we can now use transportation and production calendars as part of that optimization. We've also added for the tactical planning, deployment optimization. So when you're working with actual orders and trying to create stock transport requests and those types of things, we have a deployment optimization algorithm. And then we also, the other big thing, and you saw a scenario that was a little bit like this, but in the demonstration earlier, but we can now plan with component validity dates. So if you've got components that are changing out as part of a product, a PDS or product data structure, we can use those in the following tactical planning runs, right? So the confirmation run, the constrained forecast run, and the optimized constrained forecast run. So when you're running those tactical planning algorithms, you can now have the validity support that comes out of your bills of material in ECC or another system could be leveraged to have components change out over time. If I go for inventory, we've actually really created a new app for all of the inventory settings, so the profiles. So we can create profiles, it's all in one place. The other piece we did is we updated some of the supply chain network app. So we can see some different network charts in a list report. And so we can see additional information and streamline looking at visualizing the supply chain network for your inventory optimization purposes. So those are sort of the big highlights that we did. If you want more details, you can go to the What's New in IBP 2005 or 2005. That's a direct link. This should work as a direct link to the documentation. There's also a general application help link. If you have any problems with this, the links are actually very easy. It's help.sap.com/IBP. That will take you to the latest documentation, and then there are links. There's a screenshot here. There's a link to what's new and other information about it, so you can get to those. And with that, I will hand it back to Dan to talk a little bit about some of the offerings.
Thank you, Todd. Thanks for the demonstration. It's really impressive as to how much new functionality SAP has been adding on a regular basis in their quarterly releases, and it does keep us consultants on our toes to keep up with all these new features being added. So thank you so much, Todd. Now, in the interest of time, I'm going to keep the next session a bit brief. Just to set the stage, as to why we have put together the integrated business planning jumpstart offerings. There is a big difference in the supply chain performance when it comes to best-in-class companies and the median performers, and that can be reflected in multiple KPIs, be it in different cycle times, be it the working capital that's locked up in the inventory, be it on time in full service levels, and so on and so forth. And one of the key reasons for that is that majority of these median companies are still using some outdated MRP-like planning software without benefiting from some of the recent advances that have happened. To address that particular need in the market, my supply chain group has put together some quick hit SNOP Jumpstart solution packages to help such companies bridge that gap with the best-in-class performers. And these Jumpstart offerings keep in mind the fast time to value in current times. The budget-friendly packages, they incorporate best practices and policies. They also keep in mind the need for integration between planning and execution, and they will help companies quickly respond to the supply chain challenges that they are facing. With that in mind, I want to quickly start with the main IBP Jumpstart offering that puts together also what SAP calls as the SAP IBP Amplify offering. They're both very aligned. So this particular Jumpstart offering gets you end-to-end demand planning, which includes historical data cleansing, statistical forecasting, and then the planners being able to incorporate any additional market intelligence. On the supply side, it also covers time series-based, unconstrained heuristics planning to facilitate distribution, inventory, production, and procurement planning processes. And then on the S&OP side, the monthly orchestration of the S&OP process. This offering also includes on-the-fly what-if planning capabilities that we demonstrated earlier today. Some of the transformative benefits include increased velocity because of the agility in your response, increased visualization of the KPIs and end-to-end supply network, reduced variability in your demand and supply, and improved resiliency and service levels. And the target audience includes companies that may still be working with spreadsheets or some older legacy systems and so on. This offering does require you to have the SAP IBP license for sales and operations planning at the minimum. And given the nature of its fixed scope, and we are able to offer it at a fixed price and with the go live in as little as 90 days. Now, there may be other customers for whom this fully templatized, no scope creep kind of approach may not work. They may have their main pain points focused into just one of the business processes rather than across multiple of them. And then they can benefit from our Jumpstart Lite offering, which can focus, say, only on inventory planning or only on demand sensing or only on inventory network optimization and so on and so forth. While there may be some others that may need a little bit more customization and may need a little bit more functionality beyond what is in the fixed scope, and they would benefit from our Jumpstart Plus offering as well. What is common across all these three offerings is that they're all based on flat file integration between SAP IBP and your ERP platform. And I say ERP platform because we are market leaders actually at integrating SAP IBP with both SAP ERP ECC S/4HANA as well as non-SAP platforms. There may be a fourth category of companies that require some moderate to extensive level of customization to meet their unique business requirements. They also may need a fully automated system-driven integration between the SAP IBP and their ERP solution, and they might then benefit from our Jumpstart Pro package. All of these packages come with our predefined templates, be it for data views, dashboards, predefined KPIs, predefined alerts, predefined templates for scripts, and so on and so forth. So all of them really offer a very convenient, quick to value kind of packages that we have put together. In the end, key takeaways from this webinar today, we all know that the supply chain vulnerabilities and the limited risk mitigation capabilities we have been brought to the fore. Now, fortunately, I hope you saw that the SAP IBP solution has the capabilities to effectively counter these disruptions. My supply chain group has the expertise, methodology, and pre-configured IBP Jumpstart solutions to help you with this resurgence beyond current disruption. And most importantly, how you manage the present crisis to balance resilience, efficiency, and agility can redefine your competitive landscape. So I hope we all look at these current problems as much as an opportunity for the future as the pain that they obviously are. With that said, please feel free to contact us for any complimentary one-on-one sessions to focus on your pain points and how the business strategy can be customized to meet your unique requirements. With that in mind, thank you for joining us today. If there are any questions, we'll be happy to take those, and you can unmute yourself and ask any questions.